the first thing we're going to talk about specifically as far as polynomials go is a very specific type of polynomial function called a linear function. It is a polynomial function of degree 1, and it has the form up there. It says f of x equals ax plus b, where a and b are constants, and a does not equal 0. You may be more familiar with it as being y equals mx plus b. That's saying the same thing. Point slope form, which he just drew an arrow to, is like the most important formula, I would say, in the world.
I mean, if you can do point slope formula, you can do anything, but you can't do like slope intercept. Like, that's only good for slope intercept. Point slope.
Point slope is the best way to go.
You're going to use it in conic sections, which is going to be in the spring. You're going to use it with any parent function that you investigate. It's going to be all over trig.
Yeah, it's just all the time.
It's
point
there.
slope. Let's use it. So what that formula looks like is it has a y and an x that just stay as y and x. It has m, which is the slope of the line, and then you have to have a point, which is the x1, y1. And you plug in the slope, x1 and y1, and then that's your equation of your line. And for the purposes, especially of the AP Calc test, there is no reason to simplify that into slope-intercept form.
No reason at all.
You could if you wanted to.
But you make a mistake and you're toast.
Yeah, so we would like for you to just leave it as point-slope form. And they were crafty with the name. There's a point and the slope, and it's right there, and it's called point-slope
Some
form.
genius did that and has earned thousands of dollars.
I seriously doubt that.
Well, maybe.
Maybe Mr. Point or Mr. Slope could tell us otherwise.
Well, it's like the one guy proved that if you have 6 pigeonholes and 7 pigeons, that one of the pigeonholes has 2 pigeons in it. And he got paid a ton of money to do that. So I'm just saying it's possible.
I don't know where that came from. Example 2. This is exactly like some of the problems in our assignment. So write an equation for the linear function f satisfying the given conditions. The way they wrote this is weird. They are telling us about 2 points because f of x means that what's in the parentheses is what x is. So we have a point for this first one. That would be -3, 4.
Sorry, -3, 4.
-3, 4 is our first point that we get from f of -3 equals 4. And then our second point would be 3, 6, because we have f of 3 equals 6. Now we need to find the slope, and then we need to plug in the point slope. So I didn't put the slope formula on there. Maybe we should put that somewhere.
Here's what you do. You stack your points up like this and you just subtract them.
Oh, well, that's one way of doing it.
How about that? And then, you do
put
y
over
first.
x.
So you're going to do 4 minus 6 over -3 minus 3. Order is taken care of. Nothing gets out of whack. Everything's appropriate.
Brilliant.
Sign is good. So I have -2 over -6, which I believe is 1/3.
That's right, because the negatives cancel each other out. You divide by 2 on the top and bottom, so that's 1/3. What if you wrote out the slope formula? Just in
If
case
I wrote out the slope
really,
formula,
really
one thing that will super come in handy in calculus classes if you just get into the habit of always going your stopping point minus your starting point, which would look something like this. y2 minus y1 divided by x2 minus x1.
And that's what he just did.
And that's your slope.
Okay, so that's our slope. We need to take that in one of our points and plug it into point slope formula.
I choose this point.
Okay, let's choose that point. So that's -3, 4. That's our x1 and our y1. So we plug it in. Y minus y1, which is -4, which is 4, equals 1/3 times x minus a -3. Now, the minuses next to each other there, you might notice you do that thing that you learned a long time ago, ching chang, walla walla bing bang. That becomes +3. So there you go. That is the equation for the slope of this line. We could also, though...
Ching chang, walla walla bing bang.
Yeah.
I like it.
Yeah. Isn't that how they learned it?
I think it's a click was how some of
Click.
some of the kids learned the click
bang bang, bling bling, whatever. So if you were to solve this for y, we don't have to. Why are you solving for y?
Some kids just, they're real OCD about how they like their problems to look, so,
If you wanted to solve for y, you have to add the 4 over, you have to distribute the 1/3.
No, you don't have to. You could, you could leave it like this.
Well, okay.
I think both of those are good.
Okay.
Some kids just like to have a y all alone.
Okay. We need to graph it.
Right, well, I'm out of space.
Up there in the right
Okay,
corner.
up here, right corner. So I'm going to graph the point negative 3, 4.
Negative 3, 4.
Negative 3, 4. There's my point. My slope is down 1, forward 3, or I could just plot the other point.
Don't you mean up?
That's
1,
what I
over
said.
3?
Yeah.
Or
So
you could just plot the other point and draw the line that goes between them.
3, 6. And I'm going to connect those suckers with a straight line.
Straight-ish.
Okay, so hold on.
It's okay. Don't worry about it. There it is. There's the point.
There we go.
Good to
right
go.
through.
So
Perfect.
there's actually more than one answer to this, though, right? Because they could have used the other point.
They could have.
So you could have gotten y minus 6 equals 1/3 times x minus 3, and then that would be from the other point.
Exactly.
All right.